Hey everybody, this is Mark Smith, the host of Digital Roughnecks, and I'm here with my co-host and also the product guy at
Yep.
CleanConnect.ai, David Conley.
Hey, how are you?
We're going to be talking about something that we've been thinking about a lot about and actually experimenting with, and it's this whole concept of autonomous LDAR. And let's define what that is. So, today people do what's called LDAR, leak detection and repair, using OGI camera. We call it the dude with the FLIR GF320. And like this graph here, 90% of the people in Colorado use this method versus AVO, or audio visual olfactory. Okay, soap and bubbles, also called. So this is the method. This is how people do it. So what would it look like if you were to go today's manual versus tomorrow's automated? So I put this chart together really to kind of think through it. And so Dave and I are going to go through each one of these. But today, you have to do inspections everywhere in the US, at least every 6 months. That's called Quado A regulation. Now, in Colorado was every month. And in fact, on May 1st, 2021, it turned into continuous, starting with what? Starting with new sites and
pre-production. So the continuous rules pre-production in the first 6 months of production. That's the Reg 7. Now, the whole thing that prompted this autonomous LDAR was what you were keeping me apprised of, was the Quado B conversations that are happening at the federal level. So that I don't know much about, but I do know that's what's prompted this. And I don't know if anything's been released from that yet, but
no. So they're discussing, increasing the frequency of inspections from every 6 months to every month.
Right.
So kind of catching up to where Colorado already is and has been.
Right. So I think that's another indicator. I think it's not just Colorado. I mean, I think that
right, and I think there was an EPA conference talking about methane leak detection,
right.
And the general consensus is it's moving to continuous. Okay, so there are a lot of different technologies, from satellites to planes to sensors, and including our CleanConnect OGI continuous solution. Sure. So it's moving to continuous. So that's autonomous LDAR continuous. Okay. Now, a big factor in this is human training. Okay. So you can't just take a guy off the street, hand him one of these, GF320s and say, go for it, man. I mean, there's thermography school plus just years of experience. And we are really understanding more and more about what that's all about, because we have to train the AI to do what a multi-year experienced LDAR guy can do. And that's not easy. I mean, we hands off to these guys who have, who've inspected 400 plus sites, right? But, the goal really for autonomous LDAR is get it down to, hey, 1 hour of training with the software and you can actually be effective. Okay. Sure. Detection limits. You've seen a lot of handheld footage, and the one common thing we see is it's kind of shaky.
Yeah, a little rough to look at.
It's like 10 to 20 feet maybe is what a human can hold. And beyond that, you can't hold it steady, right? And, you mount something fixed and, 300-foot radius, you can do it, right? Totally doable. And what do you mean by diameter? So what is that? Because it's
on a pan and tilt. So, I mean, our system is actually going 360 degrees, and we're looking 300 feet in either direction. So a total of 600 foot in diameter is around where our detection limit is. So,
yeah. And, people who've, everybody we're probably talking to has one of these handheld FLIR GF320s, 120,000 list. I'm sure people got discounts or whatever, but
sure.
In autonomous LDAR, it's more like the as a service pricing, right? And FLIR has an equivalent core called the G300A to the GF320.
Has a different lens, though.
Different lens, okay.
It's important, because a lot of, especially if somebody's watching this is an LDAR guy or familiar with the process, they're thinking there's no way a GF320 is going to see 300 feet. I can guarantee it. So that's one thing I do want to point out, is it is a different lens. It's a narrower field of view. So we're seeing further.
Okay.
We give up some of the wide angle.
But since you can control the tours, you can really actually define the tour
Yeah,
to get down to literally a piece of equipment.
absolutely. Yeah.
And currently, hey, detection is subjective by the operator. It really is up to the human being with that camera to say, hey, I see a leak or I don't, right?
Right.
And with autonomous LDAR, it has to be objective. It's a machine saying this is a leak or it isn't, right? Objective. Telemetry data, there really is none with the manual system, but here we can do all kinds of stuff: size, duration, location, equipment, wind speed, all kinds of stuff
Absolutely.
for every time there's an event. And then SCADA integration, none. And here there's yes, it's fully integrated with your SCADA system like Signet or whatever.
Yep.
Manual reports, there are LDAR manual, automatic call outs. This was the kind of the thing that really surprised me, that the number one safety issue I thought would have been something blowing up on a site, but it turns out it's the truck accident.
Yeah, absolutely.
Guys getting in trucks,
Going to and from
driving
site,
out to
on the
site and
road.
get an accident, you know? And since 97% of these scheduled LDARs don't result in a reportable leak, that's a lot of truck, scheduled runs that,
It's a lot of emissions.
yeah. So really, I mean, think about it. That means only 3% of the alerts required an on-site repair. That's kind of interesting.
Yep.
And then, so you're really shifting the way. So instead of doing schedule runs and finding there, the idea is, hey, get these alerts and only send a repair guy out if there's actually a leak to fix that you verified visually. I don't know what you'd call the difference of that, scheduled versus
A dispatch.
dispatch. Okay.
Yeah,
And quantification, the current methods have none, right? It's human interpreting, hey, it's a leak, but there's no quantification. And then with autonomous LDAR, yeah, the system has to be able to quantify it because it has to be able to tell what's normal and what isn't.
right.
We could talk a little bit more on another slide, but carbon fees, in Colorado, people pay carbon fees, APENs or whatever. And eventually that's coming to all the US, where it's the difference between the EPA formula and what you can prove on your methane intensity could result in millions of dollars of carbon fees. Mm-hmm. So this is something that we've had to get into with the LDAR, what I call the Turing test. In 1950, Alan Turing introduced a test to check whether a machine can think like a human. Can I communicate with you? And I can't even tell the difference between the AI and that. So with AIM, the approved instrument measurement method, they have a similar test, and they basically say, hey, can your AI system or your equipment, your AI process detect equivalent to a human with a GF320, or what's also known as EPA method 21? Mm-hmm. The big thing though on the human side is, according to the Zimmerly report, that they found a huge difference is dependent on the experience of the LDAR operator, and they separated at 400 plus sites. You're nearly twice as likely to find a leak as someone who's less experienced. And that's a big deal because I don't know, how long would it take to get, to do 400 sites, assuming you worked every single day, right? You're looking at, a year.
I think they can do 3 or 4 a day, maybe.
Okay. So, they got 1 to 2 years experience plus whatever, thermography school and whatever. But I think the big thing is, it's the quantification, right? Because at some point you're looking at a piece of equipment, and why is some emissions okay and some not?
Permits.
Okay.
Equipments are permitted to emit a certain amount. It's whenever it goes over that you really have to start figuring stuff out, because that's what you're getting fined on. That's the carbon fees. You're literally every bit of gas that's coming into the air that's not permitted, now you're getting fined for it. So
like an ECD would say, hey, it's got to burn off whatever 99%, and so there's a certain amount of emissions that come out that are normal, but then beyond that is now finable.
Yeah, correct.
Okay. Yep. And so each piece of equipment has similar kind of normal and abnormal behavior. Is that right?
Yeah, I mean, like a piece of pipe that's run like a pipe rack, there should be no leaks, right? Those are not, that's not permitted to do anything. Now, things that are venting, dehighs, treaters, I mean, even treaters shouldn't, but some depending on like the pneumatic controls and things like that. But yeah, those are permitted to a certain amount, right? And it's that's where the whole site and source level where everyone's trying to get to that understanding, okay, how much am I leaking for real at the source of the gas?
Right.
And
And
that's,
yeah,
it
because you don't
there.
want to send it, hey, that's a leak, when somebody, a human would say, that's not a leak. That's
That's a vent. That's a
yeah.
supposed to
You
happen.
even said something the other day, like a tank burping. What the heck is
Yeah.
that?
Yeah. Well, what happens is if it's it can create a vacuum, right? So if it stays sealed, I believe you can actually crush your tank whenever you start uh uh if it stays sealed and it can't let the air out, it can literally crush your tank. It can implode it. So yeah, a tank, like a tank can be permitted to leak a certain amount. In Colorado, they're going away from that real quick. I don't even think that's a thing in Colorado anymore, but I had a couple guys down in different areas. I won't even say it because it'll be too obvious, but that have those tanks that are supposed to burp. They're burping up there, and it gets down to the point where, like, we'll have to tune the model to say, okay, now this is normal. Now, if it's emitting more than this, let me know. Happy
Right.
sad face kind of thing. And that's whenever we can really customize reports and look at that type of stuff. So
So
yeah.
now the next hit, because it's LDAR, leak detection and repair. So how do unless we got robots that could literally go in there and
Cool.
fix something, which would be really cool.
Yeah.
Meanwhile, it turns out that about 80% of all LDAR is outsourced. So there's lots of guys out there that can service a particular operator, not just their in-house team. But where this is, we think, going to go is autonomous leak detection. As we mentioned, you find a leak and then you hire a repair company, like an Uber type thing, right? Hey, I need a repair. Here's literally
crews.
Roustabout
crews.
Okay.
Yeah,
and they go in and like, if you were to send them, here's where it is, here's the equipment, here's the video or the image of it, go fix that. Will you bid on this? They bid on it and they say, yeah, I'll go do it. Where we think it's going, though, is then you could create a smart contract, send the repair team. And if you had a continuous visual LDAR, you could verify, hey, did it get fixed?
Absolutely. And one of the biggest deals about this, honestly, it's actually having the right people fix the problem, right? Pumpers, like, a lot of times pumpers get stuck having to do this stuff because it's their site they go through, when in reality they could add, the companies could start scaling more vertically, and they know this, and your pumpers can go a lot further without having to stop and repair this. You can get the roustabout crews out there that come behind them and actually do the repair work a lot quicker and more efficiently, and not have to take time out of the pumper's route to stop and fix something. So it works out really well.
So where this is going to go is, right, so you autonomously hire a crew, you can visually verify that they did it, again, autonomously. You fulfill it through a smart contract, and this is a blockchain symbol because a lot of smart contract technology exists. And once it's fulfilled, then you can just go autonomously pay the repair company, all autonomously. So really, that's how the whole thing would work, from autonomous leak detection and repair. And we believe this is going to be happening actually sooner than later.
Sooner than later. That's right.
Sooner or later. And we do think that Quad OB is going to be a big catalyst to push a lot of companies who all of a sudden are facing the prospect of having to hire 6 times more, LDAR resources, because you're moving from every 6 months to every month. So anyway, if anybody's interested in following up with us, has some questions about this, here's David and I's email, mark@cleanconnect.ai and David at cleanconnect.ai. So anyway, I look forward to talking with you about that. And I'm sure we'll be sharing more episodes about autonomous LDAR.